Tonight, we slip beneath the surface of a shallow coastal sea into water warm enough to hold light, where something moves that does not quite resemble anything we have a word for. Not a fish, not a plant, not quite any category we learn to trust. Something else. Hello there, and welcome to Deep Sea Slumber. There is an animal living in the world's oceans that has no bones, no spoken language, and no face that resembles ours. And yet it appears to think. It solves, it watches and considers and decides. It has 3 hearts, and blood the color of the sea itself, and a body so soft it could pass through your hands like water. And in less than a single second, that body can become something else entirely. A different color, a different texture, a different thing altogether. Not because it is hiding exactly, though it can do that too, but because its skin is, in some way, we are still learning to understand, alive with intention. Cuttlefish have been here for a very long time, long before the first human hand reached toward the ocean and wondered what lived inside it. They belong to a lineage so ancient it predates the shapes we now think of as normal. And yet, here they are, still, moving through seagrass meadows and sandy shallows, hovering in the water column with a stillness that seems almost deliberate, watching the world with eyes that are shaped unlike any eye you have seen before. They are not large. Most could rest in your open hands. But the question they raise is enormous. What does it mean to have a mind distributed through your body? What does it mean to speak in light and texture rather than sound? What does it mean to vanish, not by leaving, but by becoming the thing you are standing in front of? We do not have complete answers to those questions, but tonight we will sit with them together, which is its own kind of knowing. We will travel through the biology of a creature that seems to blur every line we draw between animal and signal, between camouflage and communication, between the self and the world it moves through. We will look at the architecture of a body full of contradictions, soft and precise, ancient and intricate, fleeting, and somehow deeply familiar. And somewhere in that looking, something in you may begin to loosen, the way water loosens around a stone, the way the sea at night settles into itself when the wind has stopped. That is what this channel is for. Not to excite you, but to fill you with the particular quiet that comes from encountering something genuinely astonishing. The kind of quiet that makes the world feel larger and somehow safer. The kind that lets you rest. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. Now, let your shoulders drop a little, not all at once, just enough. The way they drop when you finally stop carrying something you had forgotten you were holding. Let your breath find its own pace, slower perhaps than it was a moment ago. There is nothing here that requires urgency. Nothing in the deep water moves quickly unless it has chosen to. And tonight we have chosen to be still. We are sinking very gently, the way light sinks into deep water, not falling, not rushing, but softening as it goes, becoming something quieter the further down it travels. The surface is already above us. The sounds of the day are already far away. Somewhere below, in the dim and shifting light of a coastal sea, something is watching the sand beneath it and becoming the sand. Something is hovering, breathing slowly through a siphon, adjusting the 10,000 tiny cells in its skin the way a musician adjusts a note. Not thinking about it exactly, but responding, attending, alive to everything around it in ways we are only beginning to name. We are going to spend some time with that creature tonight. We are going to learn its body and its habits. We are going to look through its strange and beautiful eyes. We are going to follow it through seagrass and open water, through the rituals of hunting and resting, through the astonishing act of simply being what it is, which turns out to be one of the most quietly remarkable things on this planet. And as we do, I hope you will feel yourself becoming a little more still, a little more like water at rest, a little more like something that has found a place to be and settled there and does not need to go anywhere else tonight. Let's begin. The first surprise is often the skin, because it seems to do something skin should never be able to do. Watch a cuttlefish settle onto a patch of sand beside a rock, and what you witness is not hiding. It is something closer to transformation. The body does not merely become harder to see. It becomes the sand. It becomes the rock. The pattern, the texture, the contrast between light and shadow, all of it arrives on the surface of the animal in less than a second, as though the cuttlefish has simply decided to stop being itself and become the world around it instead. That is not a metaphor. It is almost exactly what is happening. The skin of a cuttlefish contains 3 distinct systems, each doing something different, and all of them working at once. The first layer holds the chromatophores. These are not pigment cells in the way most animals have pigment cells, sitting passively in tissue, simply being the color they are. Chromatophores are mechanical. Each one is a small sac of pigment: yellow, orange, red, brown, black, surrounded by a ring of muscle fibers. When those muscles contract, the sac stretches outward, spreading the pigment across a wider surface, making the color visible. When the muscles relax, the sac retracts, the pigment concentrates, and the color effectively disappears. The cuttlefish does not secrete color or absorb it. It flexes it. And it can flex thousands of them, independently, in patterns that shift and ripple across the body in real time. That is already strange. But the chromatophores are only the beginning. Beneath them lies a second layer, iridophores. These cells contain no pigment at all. Instead, they are built from stacks of thin reflective plates, protein structures arranged at precise intervals, like a biological diffraction grating. When light passes through these stacked layers, it separates and reflects back at specific wavelengths, depending on the spacing between the plates. The result is iridescence, structural color, the same phenomenon that makes a soap bubble shimmer, a peacock feather glow, a beetle's shell appear to shift from green to gold. The iridophores do not need a color to be that color. They create it from geometry and light. Some iridophores in cuttlefish can also be actively tuned. Certain species appear able to change the spacing between those reflective plates, shifting the wavelength of light they reflect, and therefore the hue that appears on the surface. This is not fully understood yet. But the possibility that the skin might also contain a layer capable of adjusting structural color in real time suggests a depth to the system that researchers are still working to measure. Beneath the iridophores lies the third layer, leucophores. These scatter light broadly, reflecting back whatever wavelengths are present in the surrounding environment. They act as a kind of broadband mirror, helping the skin match ambient brightness and local color temperature. On a reef full of blue-green light, they reflect blue-green. On sandy shallows lit by warm afternoon sun, they reflect that warmth back. They do not add color so much as they amplify what is already there. 3 layers, each doing something distinct, all active simultaneously. The chromatophores controlling pattern and contrast, the iridophores generating structural shimmer, the leucophores tuning the whole display to match the ambient world. What this means is that the skin is not a surface, it is a system. The control of this system is direct and immediate. Chromatophores are connected to the nervous system by individual motor neurons, meaning the brain, or more precisely, the vast network of neural tissue that governs cuttlefish behavior, can address individual cells or groups of cells as discrete units. The resolution is extraordinary. A cuttlefish can produce fine-grained, high-contrast patterns, small dark spots on a pale background, sharp edges between differently textured regions, disruptive bands that break up the body's outline against a complex background. Researchers who have studied cephalopod skin have described watching chromatophore waves, visible ripples of activation spreading across the body like a slow tide, or a fast one, or a stuttering pulse. These are not random. They are coordinated expressions of information being processed and expressed in real time. The skin is not passive, it is broadcasting. Cuttlefish camouflage falls into recognizable categories, and researchers have given them names that feel almost too plain for what they describe. Uniform, mottled, disruptive. A uniform display is the simplest. The body adopts a single consistent tone, blending into backgrounds that are themselves uniform. Pale sand, open water, flat rock. The texture of the skin remains smooth. The goal is to become a surface, without features. A mottled display introduces variation, irregular patches of light and dark, mimicking the dappled appearance of sandy or gravelly substrates where the light plays unevenly. The skin develops a texture in both pattern and, in some cases, in actual physical dimension. Small bumps and ridges rising from the surface, controlled by pupillae, which are tiny muscles capable of raising the skin into 3-dimensional shapes. The cuttlefish does not merely change its colors, it changes its texture. A smooth body becomes a rough one. A flat surface becomes a surface with grain. The disruptive display is the most visually striking. Large, high-contrast patches appear on the body. Bold white blocks against dark backgrounds, or dark shapes against pale ones, arranged to fragment the animal's outline, to make its edges disappear, to prevent any observer from reading the whole shape as a single object. This is not matching the environment so much as interrupting the visual process itself, introducing false edges that confuse the eye before it can resolve them into an animal. These categories are not rigid. A cuttlefish can move between them, combine elements of them, and produce displays that researchers have not yet fully classified. The repertoire is large, and it is generated not from a fixed set of templates, but from a flexible, moment-by-moment reading of the world. This is perhaps the most difficult thing to hold in mind, and the most important. The cuttlefish is not running a program. It is not retrieving a stored image of sand and projecting it outward. What appears to be happening is that the animal perceives its environment, takes in the brightness, the contrast, the spatial frequency of patterns, the direction of light, and generates a response that is specific to that reading. Change the environment slightly, and the display changes. Move the animal to a new substrate, and within a second or two, it has produced a new display suited to the new surface. This means that every act of camouflage is an act of perception first. The skin cannot do what it does without the eye feeding it information. The eye cannot produce useful information without the brain passing it. The brain cannot generate a display without the skin executing it with precision. The whole loop is continuous, and it runs faster than thought. Or rather, it is a kind of thought, just not the kind that requires words or deliberation. The body is reading the world, and the skin is the answer. There is a famous experiment, and it is worth knowing about quietly in the dark, because it says something worth sitting with. Researchers placed cuttlefish on substrates made of checkerboard patterns, high-contrast black and white squares, at different scales: small squares, medium squares, large squares. The cuttlefish responded differently to each. Small checks produced a mottled display. Medium checks produced a disruptive display, with the animal's white patches roughly matching the scale of the squares beneath it. Large checks, which appeared more uniform at the scale of the animal's body, produced something closer to a uniform display. The animal was not just matching color, it was reading spatial scale. It was asking, at some functional level, how large are the features of this surface relative to my body? And it was generating a response calibrated to that relationship. This is not simple, this is not a reflex. Something in the cuttlefish's nervous system is performing a kind of spatial analysis, an assessment of the visual environment's statistical structure, and translating that analysis into a body-wide pattern in under a second. And it is doing this, as far as we can tell, without any clear ability to see color. That last part deserves to rest here for a moment. Most cuttlefish appear to have only a single type of photoreceptor in the eye, which is generally understood to mean they cannot distinguish wavelengths of light the way color-seeing animals do. They may experience the world in something closer to grayscale, and yet they produce camouflage that, to human eyes watching from above, appears to match the color of their surroundings with remarkable fidelity. How does this happen? One possibility involves the W-shaped pupil, something the next section will look at more closely. The unusual shape of the pupil may allow the cuttlefish to sample light at different wavelengths through a process called chromatic aberration, using the optics of the eye itself to extract color information that a single photoreceptor type would not normally provide. The physics of lenses means that different wavelengths of light focus at slightly different depths. An eye that can rapidly shift its focal plane, or that samples light through a pupil shaped to receive multiple focal depths simultaneously, might reconstruct something like color from what would otherwise be a colorless image. It is a workaround, an elegant, deeply strange workaround that turns a limitation into a solution. The cuttlefish may not see color the way we mean when we say color, and yet the skin knows what the background looks like. The skin produces the right answer. Whatever the eye is doing, it is providing enough information for the system to work. What does all of this mean when you hold it still and look at it? It means that camouflage in this animal is not a passive state. It is not something the cuttlefish is. It is something the cuttlefish does continuously in response to a world it is constantly reading. The skin is not a disguise put on once and worn. It is a live signal, updated moment to moment, as responsive to the environment as any action the animal takes. In a sense, the cuttlefish is always paying attention. Its body cannot help but pay attention. The skin will respond to a change in the substrate, whether the animal is hunting, resting, or simply drifting. The loop between perception and expression is always running. There is something in that worth thinking about slowly. An animal whose body is perpetually in conversation with its surroundings, not asking the world to overlook it exactly. More like listening to the world carefully enough to speak back in its own language. The skin is not hiding, it is answering. And there is still more the skin can do. Things that have nothing to do with blending in. Things that are almost the opposite. Patterns that pulse and move and flash. Displays directed outward, toward other cuttlefish, toward rivals, toward mates. A whole second life happening on the same surface, in the same cells, using the same machinery. But that is a different conversation for a later hour. For now, the sand is still. The cuttlefish is still. The skin has settled into something pale and quiet that matches the pale and quiet seafloor beneath it. And if you did not know to look, you would not see it at all. You would see only sand and rock and the slow drift of water above both. And somewhere in that stillness, a mind is reading the world, and a skin is writing it back, and the whole thing continues without effort or announcement, the way most remarkable things do. Beneath those shifting colors is a design just as unlikely, assembled from softness, pressure, and exquisite control. A cuttlefish has no skeleton. Not in the way a fish does, not in the way most animals that move with such apparent purpose do. What it has instead is a cavity full of soft tissue, a mantle wrapped around organs, and 8 arms and 2 tentacles arranged around a mouth that contains a beak. A beak, hard and sharp and hidden at the center of all that softness, the way a secret is hidden inside something that seems to have nothing to conceal. It is a strange thing to find there. It is also exactly what is needed. The beak is made of chitin, the same material found in insect shells, in the claws of crustaceans, in the hard edges of things that have learned to grip and cut. It is dark and curved and strong. It can pierce crab shell, sever the cord of a shrimp's nervous system, tear through the bodies of fish far larger than you might expect. The softness of the cuttlefish does not extend to its hunger. That is its own kind of design, to appear from the outside as something without hard edges, and to carry one precisely where it matters most. The arms come first. 8 of them, fanning from the base of that beak, lined along their inner surfaces with suckers. Not clamps, not hooks. Suckers, delicate and muscular and capable of fine individual movement, each one adjusting its grip independently. A cuttlefish reaching towards something does not move like a hand grasping. It moves like something thinking through touch, each arm exploring a slightly different angle, each sucker tasting the texture and the resistance of whatever it meets. There is sensitivity in those arms that is difficult to overstate. They are not just extensions of the body, they are instruments. And then there are the 2 tentacles, which are something else entirely. Longer than the arms, thinner, and kept partially retracted when not in use. The feeding tentacles are not for gripping or sensing. They are for speed. When a cuttlefish has positioned itself, when the moment is right and the prey is close enough, the tentacles shoot forward. Not slowly, not gradually, in a strike that takes roughly 15 milliseconds. 15. The human eye cannot follow it. The prey rarely can either. The ends of the tentacles are club-shaped, lined with suckers arranged in rows, and they contact the prey and hold it in the instant that the arms close around it. From stillness to capture in less time than it takes to blink. What makes this remarkable is not just the speed, it is the control. The tentacles are not simply launched and retrieved, they are aimed. They extend in a specific direction, at a specific target, at a specific moment chosen after what appears to be genuine assessment. The cuttlefish does not fire blindly. It waits, adjusts, and then fires with extraordinary precision, speed and patience in the same body. That combination is rarer than it sounds. The arms pull the prey toward the beak. The beak does what beaks do. And the radula, a ribbon of small teeth found in most mollusks, another structure hidden inside the softness, rasps and draws the tissue inward. There is an entire dismantling apparatus tucked inside an animal that can make itself look like drifting sand. 3 hearts keep all of this moving. 2 of them are branchial hearts, positioned at the base of each of the 2 gills, pumping blood through the gill tissue where it picks up oxygen from the water. The 3rd is the systemic heart, which receives that oxygenated blood and sends it out through the body. 3 separate pumps, working in coordination, supplying a nervous system and a musculature that make constant, complex demands. The system works, but it has a cost that is worth knowing about. When a cuttlefish swims using jet propulsion, drawing water into the mantle cavity and expelling it forcefully, the 2 branchial hearts slow significantly. The effort of sustained swimming reduces the efficiency of oxygen delivery. This is why cuttlefish, like octopuses, tend not to swim long distances by jet. It is expensive. The body can do it, but it prefers not to. This is a creature that has, in a sense, solved many problems and accepted a few specific limitations in return. The limitations shape the behavior. Slow, deliberate movement becomes not just a preference, but a kind of physiological wisdom. The blood itself is worth pausing on. It is blue. Not as a metaphor, not as a description of how it looks in certain light, genuinely chemically blue, because the protein that carries oxygen through cuttlefish blood is not hemoglobin, which uses iron and runs red, but hemocyanin, which uses copper and runs blue when oxygenated. It turns pale, almost colorless, when the oxygen has been delivered. The blood cycles between blue and near transparent with every circuit through the body. Iron carried the oxygen of one lineage. Copper carried it in another. Both solutions work. Both are ancient. Life arrived at 2 different answers to the same question and kept both of them in different bodies across hundreds of millions of years. Even at the level of blood, the animal kingdom does not follow one plan. Now consider the cuttlebone. It is not a bone. The name is inherited from the way it was once understood. Washed up on beaches, pale and lightweight, collected and used as a calcium supplement for caged birds, which is still done today. But structurally, it is something far more interesting than a bone. It is an internal shell. Cuttlefish are mollusks, and mollusks began with shells. Snails still have them on the outside. clams still have them on the outside. But somewhere in the long history of cephalopod evolution, the shell moved inward. In nautiluses, it is still largely external, chambered and beautiful, used for buoyancy control. In squid, it has become a thin, transparent sliver called a pen, almost vestigial. In cuttlefish, it occupies a middle space, internal but substantial, still serving an active and essential function. It is a remnant of something ancient, repurposed into something new. The cuttlebone is a flattened oval structure that sits along most of the animal's dorsal surface, inside the mantle. It is made of calcium carbonate, like a shell, but its interior is not solid. It is a complex lattice, a grid of chambers separated by thin walls, each chamber capable of holding gas or liquid in varying proportions. By adjusting the ratio of gas to fluid in those chambers, the cuttlefish controls its buoyancy with extraordinary precision. It can hover without effort. It can sink slowly. It can rise without a fin stroke. The cuttlebone is a ballast system, a pressure vessel, a structural support, and a calcium reservoir all at once. One structure, 4 functions. The walls of those chambers are remarkably thin enough that cuttlefish cannot dive below a certain depth without the pressure collapsing them. This is a real limitation. Most cuttlefish species live in relatively shallow water in coastal zones above the continental shelf. The cuttlebone, which gives them such elegant control in those environments, also draws a boundary they cannot cross. The same structure that allows them to hover motionless above a sandy seafloor would fail them in the deep ocean. It is a tool perfectly fitted to a particular world, and that particular world is the only world it fits. There is something quietly instructive in that. Not a lesson, just an observation. Every solution is also a boundary. Every structure that enables one thing prevents another. The cuttlebone is not a flaw in the design. It is the design, fully committed to a specific set of conditions, trading depth for precision, trading range for control. The mantle wraps around all of this. The cuttlebone, the organs, the hearts, the ink sac, the gills, like a muscular envelope. It is the body of the animal in the most immediate sense. The fins run along its edges, undulating in long, continuous waves to produce gentle propulsion and fine directional control. The mantle contracts for jet propulsion. The mantle changes color in concert with the skin above it. It is simultaneously structure, engine, and canvas. Inside the mantle, tucked near the posterior end, is the ink sac. It produces a dark fluid, sepia, the word for it, which is also the word for the warm brown-grey color that the dried ink takes on. And the cuttlefish can release it into the water when threatened. The ink does more than obscure. It contains compounds that may interfere with the chemical senses of predators, disrupting the ability to track. A cloud of ink is not just a visual distraction. It is a sensory disruption, a way of making the sea briefly unreadable to whatever is following. The word sepia comes from the Greek name for cuttlefish. For centuries, artists ground the dried ink into pigment and painted with it. Drawings made with sepia ink in the 18th century still exist, still warm, still holding their color. The cuttlefish's defensive chemistry became a human art material. The animal did not intend this, but it is a strange and gentle kind of continuity. The cuttlefish still producing sepia in the dark shallows, artists still reaching for it on the shelf. The same substance, 2 completely different uses, separated by the width of the water's surface. All of these structures, arms, tentacles, beak, radula, 3 hearts, blue blood, cuttlebone, ink sac, fins, mantle, exist together in an animal that is rarely longer than a human forearm. The engineering density is difficult to hold in mind all at once. It is easier, and perhaps truer, to let it settle as a feeling rather than a list. This is a body that solved the problem of being soft in a world with hard edges by becoming, quietly, more complicated than the edges. Not stronger, not harder, more intricate, more capable of response, more full of small, elegant solutions layered over one another until the softness stopped being a vulnerability and became something closer to a medium, a material that life found it could work with in an unusual number of ways. The cuttlefish carries all of this without apparent effort. It drifts, it hovers, its arms trail loosely, each sucker still and patient. The skin shifts in small, slow waves of color, as though the body is thinking quietly to itself. There is no visible evidence of the 3 hearts, the blue blood, the latticed chambers adjusting their gas. All of that is interior. All of that is hidden. What is visible is the stillness and the small continuous motion of the fins and the eyes, which are their own remarkable subject and which have been waiting this whole time to be considered. For a body to answer the world so precisely, it helps to ask how that world is being seen in the first place. The cuttlefish eye is large, proportionally, strikingly so, set wide on either side of the head, each one a dark and complex structure that can move independently of the other. At rest, the eye looks almost familiar, rounded, glassy, attentive. But look more closely and something shifts. The pupil is not round. It is not a simple vertical slit or a horizontal bar. It is shaped like a W, or sometimes, depending on the light, like a crescent folded back on itself, like a wave caught mid-break and held there, open to the sea. That shape is not decorative. Nothing in a cuttlefish is decorative. The W-shaped pupil is a solution, an elegant and ancient one, to a problem that every visual animal faces: how to see clearly across a wide field while also managing the intensity of incoming light. A round pupil contracts to a point and expands to a circle. A W-shaped pupil can narrow without closing off peripheral vision the way a round pupil does. It keeps more of the visual field accessible even in bright conditions. It is, in some ways, more efficient, a wider aperture with more control. What makes this worth sitting with is not just the efficiency. It is the strangeness of the shape itself. Most pupils we encounter in the world, mammalian, reptilian, avian, tend toward simplicity, round or slit. The cuttlefish eye chose something else entirely, something that looks almost abstract, something that, if you saw it in a painting, might seem invented. And yet it grew, slowly, over millions of years, because it worked. The sea shaped it. The sea asked a question about light, and the eye answered with a curve. Cuttlefish eyes are positioned to give them nearly panoramic vision. Each eye covers a wide arc independently, and together they span most of the space around the animal. There is a blind spot directly behind the head, a narrow gap, but almost everything else falls within view. This matters for an animal that both hunts and is hunted. It matters for a creature that needs to read the texture of a sea floor in one direction while monitoring the open water in another. The 2 eyes can also focus at different depths simultaneously. While one eye tracks something close, a small crab moving across sand. The other can be scanning the middle distance for movement that might signal a larger predator. This is not multitasking in the way we sometimes use that word. It is something more structural than that. The visual system is built for divided attention in a way that a human brain has to strain to achieve and never quite manages. Yet the eyes do not work entirely in isolation from each other. Information from both eventually integrates. The cuttlefish builds a picture of its surroundings that is coherent and continuous. It knows where things are, how far away they are, how fast they are moving. It makes decisions based on all of this, quickly and quietly, in the dim water where reaction time can mean the difference between a meal and a missed one. The eyes are not just recording, they are already beginning to interpret. Here is the mystery that sits at the center of all of this. Cuttlefish are, as far as we can determine, colorblind. They have only one type of photoreceptor in their eyes. Humans have three. One sensitive to red wavelengths, one to green, one to blue. And it is the comparison between these three that allows us to perceive color. Most mammals have two. Some birds have four and can see into the ultraviolet range. Cuttlefish have one. A single receptor type means no comparison. No comparison means no color discrimination in the way we understand it. And yet, cuttlefish produce some of the most precisely color-matched camouflage in the animal kingdom. They sit on a red rock and turn red. They settle over pale sand and become pale. They hover near dark kelp and darken. They match not just the dominant color of a background, but its texture, its contrast, its patterning. And they do this in milliseconds, without apparent hesitation, in response to what they see. How? How does an animal that cannot distinguish colors produce a match so accurate that researchers sometimes struggle to spot the animal even when they know it is there? This question has not been fully answered. That is worth saying plainly. It is an open one. But there are serious hypotheses, and one of them is both strange and beautiful. Cuttlefish may use their pupils to see color through a mechanism called chromatic aberration. In any lens, including the lens of an eye, different wavelengths of light bend at slightly different angles as they pass through. This is why a prism splits white light into a spectrum, and it is why, in most optical systems, this effect is considered a flaw to be corrected. Red light focuses at a slightly different point than blue light. The image blurs at the edges, differently depending on wavelength. For most visual systems, this is a problem to be minimized. But the cuttlefish pupil's unusual shape, that wide, irregular W, may actually allow the animal to exploit this flaw deliberately. By adjusting the size and shape of the pupil, the cuttlefish may be able to shift which wavelengths come into sharpest focus at a given moment. In other words, rather than comparing three types of receptors simultaneously, it may scan through wavelengths one at a time, using the focus of the image itself as a guide to color. Not color as we see it, all at once, laid out in the visual field, but color as a sequence, a kind of temporal reading, the eye moving through the spectrum the way a hand moves across a surface to read texture. This remains a hypothesis. The evidence is suggestive, not yet definitive, but even as a possibility, it reframes something fundamental. We tend to think of color vision as a fixed capacity. You have it or you don't, in varying degrees. The cuttlefish may be doing something far stranger, reading color through time, through the physics of its own lens, through the very imperfections that other animals evolved to eliminate. If this is true, then color is not a thing the cuttlefish lacks. It is something the cuttlefish accesses differently. There is something else the cuttlefish eye can do that most human eyes cannot, and it may matter even more than color. Cuttlefish are sensitive to polarized light. Light, when it travels through air or water, vibrates in many directions simultaneously. When it reflects off a surface, water, glass, the scales of a fish, it can become polarized, vibrating predominantly in one plane. Humans cannot detect this directly. We can see the effects sometimes. Glare on water, the brightness of a wet road. But we cannot see the polarization itself. We need tools for that. Polarized sunglasses, for instance, block one plane of vibration and reduce glare. We built external technology to do what some animals do biologically. Cuttlefish can see polarized light directly. Their photoreceptors are arranged in a way that makes them sensitive to the angle of polarization, not just the intensity or wavelength of light. This adds an entire dimension to the visual world, one that is invisible to us, but that the cuttlefish navigates as naturally as we navigate hue or brightness. What does polarized light tell a cuttlefish? Several things. The scales of many fish polarize reflected light in distinctive ways, making prey easier to detect against a complex background. Certain surfaces, shells, transparent bodies of small crustaceans, the shimmering surface of the water above, produce polarization signatures that help the cuttlefish read its environment with more precision than color or brightness alone could provide. And cuttlefish themselves produce polarized light signals in their skin, patterns that may be visible to other cuttlefish while remaining invisible to predators that cannot read polarization. They may be having conversations that most of the ocean cannot even perceive. The sea, in other words, contains information that we simply do not receive. The cuttlefish moves through a richer signal than we have access to. It is not that the animal sees more vividly in the way we might imagine, more saturated, more bright. It is that the sea contains a layer of structure, of patterning, of signal that is simply absent from our experience of the same water. The cuttlefish brain processes visual information in ways that are still being mapped. What is clear is that a significant amount of processing happens before the signal even reaches the brain, in the retina itself and in the optic lobes, which are large relative to the rest of the brain and clearly central to how the animal functions. The cuttlefish is a visual creature in the deep sense. Vision shapes its hunting, its camouflage, its communication, its navigation. The eye is not a peripheral instrument. It is something closer to a primary way of being in the world. And yet the eye works alongside everything else. The skin is also receiving information, pressure, temperature, perhaps chemical signals from the water. The arms are touching and tasting simultaneously. The lateral line system, present in some cephalopods, may be detecting water movement. The cuttlefish is not seeing the world and then responding to it. It is reading the world through multiple channels at once, and the response, the flicker of skin, the shift of posture, the slow drift sideways, is already happening before any single sense has finished its report. Seeing, for a cuttlefish, is not a discrete event. It is continuous. It is woven into the body's ongoing conversation with the water around it. There is a quietness to this once you sit with it. We tend to think of vision as one of the most immediate and reliable ways of knowing a thing. We say, seeing is believing. We trust what we see. And yet the cuttlefish reminds us that what any eye sees is shaped by the structure of that eye, by what it is built to receive, what it ignores, what it turns into signal, and what it lets pass through without record. The cuttlefish sees polarization we cannot see. We see color it may only read in sequence. Neither is more true. Neither is more complete. They are different instruments playing in the same sea. The W-shaped pupil opens in the dim water. The polarized signals move through it. The colors arrive one by one in whatever way they arrive, and the skin begins to answer before the moment has fully passed. The eye is not waiting. It is always already in the middle of the world, reading what it can, building what it knows from the particular kind of light that reaches it. In this water, at this depth, in this quiet and ancient sea. That is what seeing can be. Not a window, a conversation. Patient, continuous, shaped by what the body brings to it and what the world offers back. Seeing, though, is only part of the miracle. The rest lies in how this impossible body moves through water almost like a thought. A cuttlefish can move in any direction without turning around. That sentence takes a moment to settle. Forward, backward, sideways, diagonally. Any vector through the water column is available instantly, without the animal needing to reorient itself. This is not how most animals move. Most animals face the direction they intend to go. The cuttlefish simply goes. The body stays still. The heading changes. It is as though the concept of facing somewhere has been made optional. This freedom comes from two very different systems working at the same time. One is built for power, the other is built for precision, and the cuttlefish uses both, choosing between them the way a careful person might choose between running and stepping lightly, depending on what the moment requires. The powerful system is jet propulsion. Water enters the mantle, the muscular body cavity that surrounds the cuttlefish's organs, through a pair of openings near the head. Then the mantle contracts. The water is forced out through a narrow tube called the siphon, and the animal is pushed in the opposite direction. The physics are simple. The result is fast. What makes this interesting is the siphon's flexibility. It can rotate, it can point in multiple directions. So the direction of the jet, and therefore the direction of movement, can be changed without moving the body as a whole. The cuttlefish steers not by turning, but by adjusting the angle of the water it expels. It is a propulsion system that is also a steering system, and both are contained in a single flexible tube. Jet propulsion is not subtle. It is the escape mechanism, the sudden disappearance, the burst that removes the cuttlefish from a situation before a predator can fully process what it was looking at. The movement can happen in a fraction of a second. The animal is there, and then it is somewhere else, and the water in between holds only a faint trace of where it was. Yet jet propulsion is costly. It demands significant muscular effort. It burns energy quickly, and it is not particularly precise. It is a blunt instrument, useful for emergencies, less useful for the patient, deliberate business of ordinary life. That is why the cuttlefish also has fins. Running along both sides of the mantle, from just behind the head to the tip of the body, are two long fins. They are thin. They are nearly transparent in some species. They ripple in continuous flowing waves that pass from one end to the other, or from both ends toward the middle, or in reverse, or in patterns that combine differently on the left and right sides simultaneously. This fin movement, called undulation, is how the cuttlefish spends most of its time moving. It is almost silent. It is extraordinarily precise. The fins can generate thrust in any direction by adjusting the direction and speed of their waves. Forward, backward, sideways, all of it available through subtle changes in how the undulation travels. Imagine watching a cuttlefish hover above a sandy seafloor, its body perfectly still in space, its fins rippling steadily on either side. The fins are doing constant work, adjusting, correcting, compensating for small currents, maintaining a precise position in 3 dimensions. But the body above them looks effortless. It looks like something that has simply decided to remain exactly where it is, and the water has agreed. This is one of the things that makes watching cuttlefish genuinely strange. They can hold position in moving water with a stillness that seems almost impossible given how soft and unanchored they are. There is no rigid skeleton bracing them against the current. There are only waves passing through thin fins, making thousands of small corrections per minute, producing something that looks, from the outside, like absolute calm. The engineering is remarkable. The appearance is serene. But neither the jet nor the fins address a fundamental challenge. How does the cuttlefish stay at a particular depth without constantly working to get there? A soft-bodied animal in water is subject to buoyancy forces that depend on its density relative to the surrounding water. Too dense, and the animal sinks. Too light, and it rises. Maintaining a chosen depth requires either constant active swimming, which is exhausting, or some way of matching density to the water at that depth. This is where the cuttlebone becomes something more than structural support. The cuttlebone is not simply a rigid scaffold, it is a buoyancy device. Its interior is divided into hundreds of thin chambers, and those chambers contain a mixture of liquid and gas. The ratio of liquid to gas determines the cuttlebone's overall density, and therefore the cuttlefish's overall density, and therefore whether the animal rises, sinks, or stays exactly where it is. The cuttlefish can adjust this ratio. Slowly, through osmotic processes, it can remove liquid from the chambers, replacing it with gas, becoming lighter, or it can allow liquid back in, becoming heavier. The adjustment is gradual, not something that happens in a second, but something that happens over hours as the animal moves between different depths and needs to match the buoyancy of its new position. What this means in practice is that a cuttlefish hovering motionless above the seafloor is not fighting gravity and water pressure to stay there. It has already solved that problem in advance by adjusting its internal chemistry to match the depth it intends to occupy. The hovering looks passive. It is actually the result of prior calculation, a slow, invisible act of preparation that makes stillness possible. This is a different kind of intelligence than the kind we usually think about. It is not reactive, it is anticipatory. The body makes an adjustment before it is needed, so that when the moment arrives, nothing needs to be done. Stillness, then, is not the absence of effort. It is what effort, completed in advance, makes possible. And stillness is something the cuttlefish uses deliberately. A motionless cuttlefish on the sea floor is not a resting cuttlefish. Or not only that, it is a watching cuttlefish, a waiting cuttlefish, a cuttlefish whose skin has already shifted to match the texture and color of whatever it has settled near, whose W-shaped pupils are tracking the movement of water above it, whose arms are held in a relaxed posture that could become a strike in a fraction of a second. The choice between stillness and movement is one the cuttlefish makes constantly, and it makes it well. There is a kind of fluency in how these animals transition between their modes, from hovering to jetting, from drifting to holding position, from slow undulation to sudden reversal. That suggests not just physical capability, but something like judgment, the right movement at the right moment, the stillness that precedes it. When threat arrives and stillness is no longer enough, the cuttlefish has one more tool: ink. The ink gland sits near the intestine, and it can release a concentrated cloud of dark fluid into the water. The cloud does not disperse immediately. It holds its shape for a moment, forming a dark mass in the water column that is roughly the size and shape of the cuttlefish itself. Then the cuttlefish is gone, propelled by a jet in whatever direction provides the most space. The ink is not simply a visual screen, though it serves that function. It also contains compounds, including tyrosinas, which interferes with chemical receptors that may disrupt the sensory systems of predators that rely on smell or taste to track prey. A shark, following a scent trail, encounters the ink cloud and loses the thread. The cuttlefish is already somewhere else, already adjusting its skin to the new background, already becoming the seafloor. There is something almost theatrical about this. The decoy, the misdirection, the sudden absence where a body used to be. The cuttlefish does not simply flee. It replaces itself with a dark suggestion of itself, and then disappears while the suggestion holds the attention of whatever was watching. It is escape as a kind of art. Not brute speed, not hard armor, not toxic flesh, but confusion, timing, and the precise use of a body that can become, in an instant, either a burst of motion or an absence of evidence. What emerges from all of this, the jet, the fins, the cuttlebone, the ink, the hovering stillness, is a picture of an animal that has solved the problem of moving through water in multiple ways simultaneously, and that chooses between those solutions depending on what the moment asks of it. Most animals specialize. They are fast or they are still. They are built for pursuit or they are built for concealment. The cuttlefish is built for both and for everything between. The body contains a quiet mode and an explosive mode and a hovering mode and a vanishing mode, and all of them are available all the time without any of them compromising the others. That is a strange kind of completeness. Not the completeness of an animal perfectly adapted to one niche, but the completeness of an animal that has kept its options open, that has remained, through all the slow pressure of evolution, something genuinely flexible, something that can always do something else. In the water column, above a sandy seafloor somewhere in the shallow coastal sea, a cuttlefish is hovering. Its fins move in their quiet, continuous waves. Its skin is the color and texture of the sand below it. Its eyes are open. It is not going anywhere in particular. It is simply here, in the water, held at exactly the depth it has chosen, watching. And that is, in its own way, enough. But anatomy is only the beginning of this story, because every remarkable structure becomes most interesting when it is used. A cuttlefish does not hunt the way a predator in a hurry hunts. There is no sprint, no dramatic pursuit across open water. What happens instead is something quieter and, in its own way, more unsettling. A slow approach that looks, from the outside, like almost nothing at all. The cuttlefish moves toward its prey as though it is not moving toward anything, as though it simply happens to be drifting in that direction, as though the space between them is closing by coincidence. This is the patient art of it. And patience, in a hunter, is a form of intelligence. The prey, a small shrimp, a crab moving along the seafloor, a fish hovering just above the sand, is rarely still. It watches. It has its own nervous system, its own alarm responses, its own sense that something nearby may not be safe. And so the cuttlefish must work within all of that awareness. It must approach without triggering the moment when the prey decides to leave. That threshold, the distance at which fear becomes flight, is the entire problem the cuttlefish is solving, step by careful step. That is why camouflage here is not decoration. It is strategy in motion. The skin shifts as the cuttlefish moves. Not randomly, not once and then held in place, but continuously, adjusting to each new angle, each new patch of background, each change in light as the animal glides forward. The texture of the mantle rises and falls to match the roughness of the seafloor beneath. The color dims or brightens to match whatever the polarized light is doing near the surface. The cuttlefish is not merely hiding. It is actively solving a problem that changes with every inch of progress. The camouflage is recalculated in real time, like a calculation that never quite reaches its final answer because the conditions keep shifting. And yet it works. It works well enough that the shrimp continues feeding, continues moving its small legs over the sand, unaware. There is something remarkable in that. Not just in the camouflage itself, which has already been explored in its extraordinary detail, but in what the camouflage is being used for. It is not being used to disappear and stay disappeared. It is being used to move, to close distance, to be present without being noticed. The cuttlefish is using concealment as a form of locomotion, and that reframes what concealment even means. It is not hiding. It is traveling in a way that the prey cannot see. The fin undulation keeps the body level. This matters enormously. A hunter that bobs or lurches will catch the prey's attention through movement, even if the coloring is perfect. But the cuttlefish, as described before, has that extraordinary lateral fin running the length of the mantle, capable of sending small, precise waves in any direction, capable of holding the body in a kind of floating stillness, even while the animal advances. From above, the body barely seems to move at all. It is the fin doing the work, quietly, below the line of easy perception. The approach becomes nearly frictionless, nearly invisible in its motion as well as its appearance. And then there is the matter of where the cuttlefish positions itself before it strikes. Cuttlefish have binocular vision in a narrow field directly in front of them. The two eyes, positioned on either side of the head, each see their own wide panorama. But there is a small zone where both eyes point at the same object, where depth can be perceived with real precision. This is where the tentacles will go. The cuttlefish, as it approaches, is maneuvering to place the prey within that zone. Not just close enough, and in exactly the right part of the visual field. The geometry of the final approach is as important as the camouflage that made the approach possible. The animal is solving a spatial problem, aligning itself for a strike that has to succeed on the first attempt, because there is no second attempt. the prey will be gone. What makes this worth sitting with is what it implies about what is happening inside the cuttlefish during all of this. It is tracking the prey's position continuously. It is adjusting its own route to account for the prey's small movements. It is managing its own appearance while doing so. It is calculating the moment when the distance has become short enough and the angle has become right enough and the prey has become still enough that the strike will land. All of this is happening simultaneously in an animal with a brain smaller than a walnut, distributed through a body that is itself doing much of the processing. The patience of the hunt is not emptiness. It is full of quiet work. At some point, and the cuttlefish seems to know when, the approach ends. The animal stops advancing. It holds its position, and for a moment the whole scene becomes very still. The prey continues whatever it was doing. The cuttlefish watches. And in this pause, something is being assessed that is difficult to name, but easy to recognize as a kind of judgment. Not quite decision, not quite reflex, something between the two. The moment when all the gathered information resolves into readiness. The tentacles shoot out. They travel at speeds that make the strike nearly invisible to a watching eye. The suckers at the tip close around the prey before the prey has processed that anything has happened. The whole event, from stillness to capture, takes less time than a single breath. And then it is over. The cuttlefish draws the prey back toward the beak. The water around it settles. The sand, briefly disturbed, drifts back down. The patience was long. The strike was not. That contrast is worth holding for a moment, because it says something about how this animal allocates time. The cuttlefish does not rush the approach and then hesitate at the end. It is slow where slowness is required, and it is fast where speed is the only thing that matters. This is not a single behavioral mode. It is a layered one, with different qualities of attention applied to different phases of the same action. Patience, then precision. Concealment, then revelation. The long stillness before the single movement that matters. Cuttlefish also show something that researchers have found striking. They appeared to adjust their hunting behavior based on what they have already eaten. An animal that has recently caught a crab, for instance, may show more interest in shrimp. An animal that has been successful in one strategy may shift tactics when the environment changes. This is not fixed programming. It suggests something more flexible, a capacity to weigh current states against available options, to change approach based on information that includes the animal's own recent history. The hunt is not the same hunt every time. It is calibrated. There is also evidence that cuttlefish can learn the behavior of specific prey. A crab that has learned to hide in a particular way, a shrimp that retreats to a predictable location. The cuttlefish can come to anticipate these patterns and position itself accordingly. This is not instinct reading instinct. This is one mind modeling another mind, however simply, however briefly. The predator is building a small internal picture of the prey's behavior and using it to hunt more effectively. That is a form of knowledge, a quiet, accumulated form. In some cases, cuttlefish have been observed approaching prey at an angle that keeps a particular background behind them, choosing a path that maximizes the effectiveness of their camouflage relative to where the prey's eyes are pointed. This is not random. It requires the cuttlefish to hold a model of what the prey can see, and to move through space in a way that accounts for that model. The hunter is thinking in some sense from the perspective of the hunted, not with empathy, with tactics. And then there are the moments when the cuttlefish decides not to strike, when it holds its position, watches, and then drifts back. This happens when the prey moves into a less favorable angle. It happens when something else enters the scene. A larger animal, a change in the light, some disruption that shifts the calculation. The cuttlefish does not commit to a hunt it cannot finish. It withdraws, it waits, and it begins again when conditions allow. This restraint is as interesting as the strike itself. Knowing when not to act is a form of intelligence that is easy to overlook because it looks like nothing. It looks like stillness. But it is a choice. The seafloor world in which this hunting unfolds is not a dramatic one. It is slow, it is dim, it is full of sand and rock and the small movements of small animals going about their own careful lives. The cuttlefish belongs to this world completely. It is built for its scale, not for open ocean speed, not for dramatic aerial pursuit, but for the near-ground, close-range, patience-requiring work of hunting in a world where everything that matters is happening just a few inches away. Its tools, the chromatophores, the fin undulation, the binocular focal zone, the fast tentacles, are all solutions to the specific problems of this specific environment. They fit together because they were shaped together over a very long time by the same pressures. What the cuttlefish hunt looks like from a distance is not much at all. A slow drift over sand, a pause, another drift, and then a movement so fast it barely registers before the water is still again. But inside that apparent simplicity, there is a great deal happening. Perception, adjustment, calculation, restraint, and finally, a single precise action that carries all the accumulated patience of the approach behind it. The hunt is not a chase. It is a conversation between the cuttlefish's awareness and the world it is moving through. A conversation that ends, when it ends well, in the quiet closing of suckers around something that did not know it was being watched. That is what patience looks like at close range. That is what intelligence looks like when it is distributed through a body, expressed through skin and fin, and the slow, deliberate narrowing of distance. The cuttlefish does not announce itself. It does not hurry. It simply waits until the moment is exactly right, and then it does not miss. And once a body can change its surface so completely, camouflage is no longer its only language. A cuttlefish moving through open water near another cuttlefish is doing something different from a cuttlefish moving through open water alone. The skin is still shifting, still reading and responding to the world around it. But now some of what it is responding to is another mind, another set of eyes, another body capable of reading exactly the kind of signal being sent. What happens between them is something that does not have a simple name. It is not quite display. It is not quite speech. It is closer to a conversation conducted entirely in light, in motion, in the grammar of a living surface. This is worth sitting with for a moment. Most animals communicate through sound, or through posture, or through chemical signals that drift invisibly through air or water. Cuttlefish do some of that too. They have postures, orientations, ways of holding the arms that carry meaning. But the primary channel of their social world is the skin itself. The same surface that hides them from predators also speaks to rivals. The same surface that vanishes them into sand also courts a mate. The same body that became a rock becomes, when another cuttlefish approaches, something unmistakably alive and unmistakably saying something. What it says depends entirely on who is looking and why. When two male cuttlefish meet in the same territory, the skin changes fast. Dark bands appear, bold, high-contrast stripes running across the mantle, the kind of pattern that would be conspicuous under almost any background. Where camouflage seeks to dissolve edges, rivalry patterns create them. The body announces itself. The stripes pulse and shift, moving in waves from front to back or flickering in place, or alternating between dark and pale in rhythms that seem almost deliberate. The arms may spread. The body may flatten and broaden, presenting more surface area, appearing larger. Everything about the display pushes in the same direction, toward presence, toward visibility, toward the message that this animal is here and intends to remain. Yet it rarely comes to contact. That is one of the quieter wonders of cuttlefish rivalry. Two males may spend several minutes in this kind of visual negotiation, shifting, pulsing, angling toward and away from each other. And then, one of them dims. The patterns fade. The body turns. The animal moves away, and the encounter ends without injury to either of them. Something was communicated. Something was understood. The information passed between them through light and pattern, and it was enough to resolve the contest. What that information actually contained, what each animal perceived and assessed and ultimately decided, that is harder to say. Size matters, almost certainly. Pattern intensity may matter. The speed and complexity of the display may carry information about the animal's condition, its energy, its willingness to continue. Rivals may be reading each other the way one might read a sentence written in a language that exists nowhere else, that evolved for exactly this purpose and no other. Courtship uses the same surface, but with different patterns entirely. A male approaching a female shifts into something that looks almost nothing like the rivalry display. The high contrast stripes may still appear on one side of the body, but the other side, the side facing the female, often shows something softer, more complex, more varied. Zebra banding on one flank, mottled calm on the other. The two halves of the body saying different things simultaneously. This bilateral split, different signals on different sides at the same time, is one of the more quietly astonishing things known about cuttlefish communication. The left side of the mantle can display a pattern, independent of the right. The chromatophores on each side receive different instructions and carry them out in parallel. So, a male flanked by a rival on one side and a female on the other can, in theory, send a dominance display toward the rival and a courtship display toward the female at the same time, using the same body in the same moment. That is not camouflage. That is not a single signal broadcast outward in all directions. That is targeted communication, different messages, different recipients, different purposes, all running simultaneously across one skin. The body becomes something like two conversations happening at once, each one private to its intended audience, each one written in a language the recipient is perfectly equipped to read. What the female makes of the male's display is its own question. She does not always respond immediately. She may continue foraging. She may shift away. She may hold still and appear to watch. Her own skin may shift. Subtle. Changes. Harder to read than the male's bold patterns, but present. researchers have observed females displaying what appear to be receptive patterns, or patterns that seem to discourage approach, though the full vocabulary of female cuttlefish signaling is not yet well understood. What is clear is that the exchange is not one-directional. She is not simply a recipient. She is reading and likely responding in kind. The eventual approach, if it happens, involves a careful negotiation of distance and position. The male may circle or approach from a particular angle, or extend his arms toward the female in a specific arrangement. Physical contact, when it occurs, is brief and precise. The male uses a specialized arm to transfer a packet of sperm near the female's mouth. She stores it and may use it later, sometimes choosing between the contributions of several males, a decision that happens inside her body, out of any observer's view. The courtship display ends. The skin settles. The animals separate and continue their separate lives. After mating, females seek shelter for their eggs. They tuck them into crevices, beneath rocks, into the branching arms of coral or the dense stems of seagrass. Each egg is coated in ink before it is laid, turning it dark. A camouflage that belongs to the next generation before the animal inside has even begun to form. The female may guard the clutch for a time, fanning it with her fins, keeping the water moving around it. She does not often eat during this period. She grows thinner. The eggs develop slowly in the ambient temperature of the water, and eventually each one opens, and a tiny cuttlefish emerges already fully formed, already capable of changing color, already equipped with the same chromatophore system that will define its entire life. There are also warning patterns, signals directed not at rivals or mates, but at potential predators. When a cuttlefish is startled or cornered, the skin can shift into something vivid and sudden. Bright flashes, high contrast patterns, rapid alternations between pale and dark that seem designed to startle rather than conceal. This is the opposite of camouflage. Where camouflage says nothing, warning patterns say something very loud. They say, "I noticed you." They say, "I am not what you expected." Some researchers believe these displays may also signal toxicity or mimic the appearance of something more dangerous. A warning that may or may not be honest, depending on the situation, depending on the predator. And then there are the patterns that seem to serve no obvious social or defensive function at all. Cuttlefish at rest, alone, with no apparent threat or rival or mate nearby, sometimes display slow-moving waves of color across the mantle, traveling bands of pale and dark that drift from front to back in a rhythm that looks almost like breathing. These have been observed during apparent sleep states, during what may be periods of dreaming or memory consolidation, during quiet moments when the animal seems to be doing nothing in particular. No one knows with certainty what these patterns mean, or whether they mean anything in the communicative sense at all. They may be artifacts of neural activity, the skin responding to something happening internally rather than externally. They may be something else entirely. They remain, for now, one of the quieter open questions. A signal without a known recipient, drifting across a body that has gone still. What all of this adds up to is something difficult to categorize neatly. Cuttlefish communication is not language in the way humans use the word. There is no evidence of syntax, no learned vocabulary passed between generations, no cultural accumulation of meaning over time. But it is also not simple instinct in the way a reflex is instinct. The displays are flexible. they vary with context. They respond to what is actually happening, to the specific individual being addressed, to the demands of the moment. A cuttlefish does not run through a fixed repertoire of signals in a fixed order. It produces something that fits, something calibrated, something that takes into account what the skin has already said and what the other body has already answered. That calibration happens somewhere. It happens in the nervous system, in the integration of visual input and social context, and whatever internal state the animal is currently in. It happens faster than conscious deliberation, or at least faster than anything that resembles deliberation in the human sense. And yet, it produces results that look, from the outside, like a form of awareness, like attention, like a kind of knowing that another mind is present and that what is said next matters. The skin carries all of it, the same surface that reads the seafloor and reflects it back, that vanishes the body into gravel and weed. And shadow also carries this, the negotiations, the courtships, the warnings, the quiet, mysterious waves of a resting animal's inner weather. It is a surface that has learned to face outward in multiple directions at once, saying different things to different eyes, holding the whole social world of the animal in the movement of pigment and light. There is something almost restful in that idea, if you let it settle. A creature that communicates without making a sound. A conversation that leaves no trace in the water when it ends. Two animals moving apart, both changed by what passed between them. The signal already gone, dissolved back into the skin, into stillness, into the quiet blue of the water above the sand. No signal exists in isolation, and no hunter belongs only to itself. Around the cuttlefish is an entire woven neighborhood of water, grass, sand, and tide. The shallows are where most of them spend the hours that matter most. Not the open ocean, not the crushing dark of the deep trenches, but the middle distance, 10 meters down, perhaps 20, somewhere between the surface light and the seafloor sediment, where the world is still readable and the hunting is still good. Seagrass meadows spread across sandy bottoms in wide, quiet plains. Reefs rise in the middle distance, offering crevices and shadows. And in between, where the sand is pale and the water moves in slow, long rhythms, the cuttlefish drifts, watching, adjusting, belonging to the place in a way that is quiet and complete. This is their neighborhood. And like any neighborhood, it is more intricate than it first appears. Seagrass is not simply a backdrop, it is architecture. The long, soft blades move in the current like slow breath. And within that movement, the seagrass creates something that matters enormously to small animals. Structure. There are things to hide behind. There are surfaces to rest near. There are shadows that shift without warning, and patches of light that fall in columns between the blades. For a cuttlefish, whose entire survival depends on reading and recreating visual texture, seagrass meadows are rich with information. The dappled light, the swaying vertical lines, the alternating dark and pale of the sandy floor beneath. All of it becomes material, raw input that the skin processes and reflects back, so that the cuttlefish becomes, in some sense, an extension of the meadow itself. The meadow also concentrates prey. Small crustaceans shelter among the roots. Shrimp pick their way along the blades. Fish rest near the bottom, tucked into the density of the grass. A cuttlefish moving slowly through this world is moving through a landscape that is, from its perspective, full of quiet possibility, not a barren expanse to cross, but a layered space to read carefully, one small section at a time. Sandy bottoms offer something different. Where seagrass thins and gives way to open sediment, the cuttlefish must shift its strategy. The background is simpler here, pale even without the texture of grass or reef, and the camouflage it requires is a different kind of work. A fine, granular stipple across the skin, a flattening of posture, a settling into stillness that makes the animal look less like an animal and more like a shallow depression in the sand, or a small pale stone, or nothing at all. The cuttlefish on a sandy bottom is practicing a kind of minimalism. Not the elaborate pattern matching of the seagrass, but the art of being featureless, of making absence convincing. And it works. Predators pass. The sand shifts. The cuttlefish waits, patient and still, until the coast is clear or the prey is close enough. Reefs bring a third kind of world. Here the complexity is vertical as much as horizontal. Ledges, overhangs, crevices, columns of coral and sponge rising from the seafloor toward the light. A cuttlefish near a reef is surrounded by edges and transitions, and those edges are where life concentrates. Prey shelters in the shadows of coral heads. Rivals patrol the open water nearby. The skin of the cuttlefish near a reef must handle rapid shifts from one texture to another, from the pale sand of the open floor to the dark, complex surface of encrusted rock, sometimes within a single, slow drift forward. It is demanding work, and the cuttlefish handles it without apparent effort, the skin simply responding continuously to whatever is beneath and around it. What this means, taken together, is that the cuttlefish is not adapted to one kind of place. It is adapted to transition, to the in-between, to the kind of coastal world where seagrass gives way to sand, where sand gives way to reef, where light varies with depth and time and cloud cover and season. That flexibility, the capacity to read any background and respond to it, is not a single trick. It is a whole way of being in the world, one that makes the cuttlefish at home in the most changeable places the shallow sea has to offer. Seasonally, many cuttlefish move, not in the grand, sweeping migrations of whales or the long navigational journeys of certain fish, but in quieter, shorter movements that follow the rhythms of temperature and reproduction. In cooler months, some species retreat to deeper water, where the temperature is more stable and the pressures of breeding have not yet begun. As the season shifts and the shallows warm, they return. This movement is not dramatic. It is gradual, a slow drift inward, following gradients of warmth and light, until the meadows and reefs of the coast are full of them again, moving through the water in their particular unhurried way, going about the work of the season. The work of the season in spring and early summer is reproduction. And reproduction brings the cuttlefish into one of its most tender behaviors, the laying and sheltering of eggs. The eggs of a cuttlefish are remarkable things. Each one is encased in a dark, ink-stained coating. The cuttlefish inks the eggs as they are laid, giving them a deep black color that makes them harder to see against the shadows of reef and rock. They are attached in clusters, tucked carefully into crevices, draped over the branches of dead coral, nestled beneath ledges where the current is gentle and the cover is good. A female will spend considerable time choosing the site. She positions each egg individually, using her arms to secure it, to tuck it into place, to make sure it holds. There is something in this that resembles care, though the cuttlefish will not remain to watch the eggs hatch. The investment is in the placement, in the choice of shelter, in the dark coating that conceals. When the eggs hatch, the juveniles that emerge are not helpless. They are small, sometimes no larger than a fingernail, but they are already cuttlefish in every meaningful sense. The chromatophores are functional. The arms are present. The eyes are open and reading the world. Within hours of hatching, a juvenile cuttlefish is already attempting camouflage, already watching, already practicing the patient stillness that will define its life. The whole architecture of the animal arrives nearly complete, and the young cuttlefish enters the seagrass and the sand as a full participant in the ecosystem, not a passenger waiting to develop. That is a different relationship to the beginning of life than the one mammals know. There is no extended helplessness, no long period of dependency. The world receives the juvenile cuttlefish, and the juvenile cuttlefish receives the world, and the exchange begins almost immediately. Within the food web, the cuttlefish occupies a particular position. It is a predator, as the earlier sections have shown. Patient, precise, capable of taking shrimp and crabs and small fish with remarkable accuracy. But it is also prey. Dolphins, larger fish, certain seabirds that hunt in shallow water, and some species of shark all take cuttlefish when the opportunity arises. The ink, the jet propulsion, the camouflage, the sudden change to a startling pattern. All of these behaviors exist in part because something larger is always, somewhere, paying attention. The cuttlefish is not at the top of its world. It is in the middle of it, navigating the same pressures it exerts on smaller animals, alert to what is above as much as to what is below. This middle position matters ecologically. Cuttlefish consume large numbers of crustaceans and small fish, which shapes the populations of those animals in the habitats they share. And in being consumed themselves, they carry energy upward through the food web to larger predators. They are a link, and links of this kind are not passive connectors. They are active participants in the balance of the ecosystem, animals whose presence or absence changes the texture of the place they inhabit. There is also the matter of what cuttlefish leave behind. The cuttlebone, which provides buoyancy during life, does not disappear when the animal dies. It is lighter than water, and after death it rises to the surface and drifts, sometimes for long distances before washing ashore. This is why cuttlebones appear on beaches far from any reef or seagrass meadow. They travel, carried by currents, becoming familiar objects on coastlines where cuttlefish themselves are never seen. There is something quietly remarkable in this. The internal skeleton of an animal that spent its life hidden and shape-shifting ends its journey on an open beach, pale and porous, and entirely visible, in a place the cuttlefish never went. The ocean has a way of eventually bringing hidden things to light. By now, the cuttlefish has moved through several kinds of space in this telling. The seagrass meadow, the sandy floor, the reef's edge, the seasonal return to shallower water, the careful placement of eggs in shadow. What emerges from all of this is not a portrait of an animal in a single place, but of an animal that is woven into a landscape, responsive to it, shaped by it, participating in it in ways that are sometimes visible and sometimes entirely hidden from view. The cuttlefish does not experience its habitat the way we might experience a familiar room or a neighborhood street. It reads the habitat continuously as a stream of visual and sensory information that the skin is always answering. The seagrass is not scenery, it is input. The sandy bottom is not a surface to cross, it is a texture to become. The reef is not a landmark, it is a set of possibilities, of shelter, of prey, of shadow, of edge. To live like that is to be very close to the world, not observing it from a distance, but in continuous dialogue with it, moment by moment, the body always adjusting to what is there. It is a kind of belonging that is more immediate than almost anything we can easily imagine. A belonging that is not felt, perhaps, in any way that resembles what we mean by the word, but that is real and complete and constant nonetheless. The seagrass sways, the sand settles, the reef holds its quiet shape in the dim water, and somewhere among all of it, adjusting its skin to the light, the cuttlefish continues. Patient, present, woven into the fabric of the place, another thread in the long and living weave of the coastal sea. By now, the cuttlefish begins to feel less like a collection of traits and more like a way of being in the world. And that shift, from collection to coherence, is where something quietly remarkable waits. A cuttlefish has a brain. That much is certain. It sits in a cartilaginous capsule near the center of the body, dense with lobes and circuits, connected to the eyes and arms and mantle by a nervous system that moves quickly and with precision. But the brain does not contain the whole story of how this animal thinks. Roughly 2/3 of its neurons are not in the brain at all. They are distributed through the arms, through the skin, through the body itself. A nervous system that is less a headquarters and more a conversation happening everywhere at once. That is not a flaw in the design. It is the design. What this means in practice is that the arms of a cuttlefish can respond to their environment without waiting for instruction from above. They can taste what they touch. They can explore a crevice with something like local decision-making, adjusting their grip and pressure and movement in ways that do not require the central brain to approve each small action. The brain sets direction. The body interprets the world in its own right. We tend to imagine minds as centralized things, a place where experience arrives, is processed, and becomes choice. But the cuttlefish asks us to consider a different arrangement, one where experience is processed at the point of contact, where the skin that feels and the skin that thinks are the same skin. Where knowing and doing are not sequential, but simultaneous. The word for what the cuttlefish might experience has no real equivalent in our language. We have words for thinking, for feeling, for perceiving. But they all assume a center, a place where it happens. The cuttlefish suggests that this assumption may be more cultural than biological, a habit of mind that comes from having minds like ours. That is worth sitting with for a moment. What cuttlefish can learn is, in itself, remarkable. They can be trained to associate certain containers with food. They can remember which locations were rewarding and return to them. They can observe other cuttlefish and learn from what they see, a form of social learning that requires not just attention, but something like inference, that what worked for another might work for me. They can distinguish between individual animals, recognizing familiar ones from unfamiliar ones in ways that suggest something beyond simple reflex. And then there is the waiting. In one set of experiments, cuttlefish were offered an immediate reward, a piece of food they preferred less, or the option to wait for something they preferred more. Many of them waited. They held their behavior, suppressed the impulse toward the immediate, and tolerated the delay in exchange for the better outcome. This kind of self-control, often called delayed gratification, was once thought to be rare outside of certain mammals, certain primates, certain species that seemed to human eyes to have enough of a mind to plan. The cuttlefish waited quietly, with what looks from the outside like patience. Whether that constitutes something we would recognize as experience, whether there is something it is like to be a cuttlefish holding still for a preferred shrimp, is a question science cannot yet answer with certainty. But the behavior is real. The capacity is real. And it does something interesting to the imagination to sit with the idea that a soft-bodied animal with blue blood and no bones might share, in some distant and alien way, the capacity to delay desire in service of something better. Curiosity is harder to measure than memory, but researchers have noted that cuttlefish, when introduced to new environments, do not simply hide. They explore. They approach novel objects. They examine things that pose no immediate threat and offer no immediate food, as though the information itself has value, as though the world is worth investigating for its own sake. This is not unique to cuttlefish. Many intelligent animals explore, but the quality of the attention is notable. A cuttlefish investigating something new will approach from different angles, extend an arm to touch, withdraw and watch, approach again. The behavior looks less like stimulus response and more like inquiry, less like instinct and more like interest. And interest, if we are honest, is not so far from wonder. The difference between a creature that responds to the world and a creature that wonders about the world may be smaller than we usually assume. Or the difference may be vast, and we simply have no reliable way to measure it from the outside. Both possibilities are equally humbling in their own way. There is something particular about the relationship between the cuttlefish's mind and its skin. The skin does not just express, it also reflects. When a cuttlefish encounters a complex surface, a field of broken rock, a patch of shell fragments, a wall of textured coral, the skin responds to what the eyes have seen, translating visual information into physical pattern at a speed that suggests something more like recognition than deliberation. The animal sees a thing, and the body becomes it, or something like it, before any conscious choice could have intervened. This raises a question that has no clean answer. Is the camouflage a thought? Is the pattern the result of a decision? Or is it something closer to what a reflex is? A response that bypasses the kind of processing we usually call thinking? Or is that distinction itself misleading? Is a fast, accurate, contextually appropriate response to a complex environment not already a form of intelligence, regardless of how quickly it arrives? We tend to reserve the word intelligence for things that feel effortful, for the slow solution, the deliberate choice, the labored reasoning. But the cuttlefish matches a gravel bed in under a second, adjusts the match as it moves, and corrects for changes in lighting and background simultaneously. If that is not intelligence, it is something that intelligence would be fortunate to resemble. Memory in cuttlefish appears to be episodic in some sense, not just a record of what was rewarding, but something that includes when and where. Studies suggest that cuttlefish remember specific past events, which location they visited last, how recently they ate, what they ate before. This kind of memory, contextual, time-linked, specific, is the kind we tend to associate with a rich inner life, with a self that persists through time, with the experience of having a history. Whether a cuttlefish has a self in any meaningful sense is again a question that remains open. But the architecture for something like it seems to be present. The capacity to remember not just what, but when. The capacity to use past experience to shape present behavior. The capacity to wait, to explore, to learn from watching others. These are the ingredients. What they add up to from the inside is something we can only approach from the outside, gently, with appropriate uncertainty. What is most striking, perhaps, is how little the cuttlefish needs to announce its intelligence. There is no performance of cleverness, no social display of problem-solving, no visible effort. The intelligence of a cuttlefish is woven into the texture of its ordinary life, in the way it waits before striking, in the way its skin adjusts before the animal has consciously moved, in the way it returns to a good hunting ground, in the way it watches another cuttlefish and files something away. It is an intelligence that works in the background, that lives in the body as much as the brain, that expresses itself not in dramatic demonstrations, but in the quiet accumulation of successful choices, successful readings of the world, successful moments of being exactly what the situation required. There is something restful in that kind of mind, not the mind that strains and deliberates and announces its conclusions, the mind that is already doing what needs to be done, already reading the world, already becoming the answer to the question the environment is asking. The cuttlefish does not appear to wonder what it is. It simply is, with a completeness that looks, from the outside, like a kind of ease. Whatever inner life it carries, however distributed, however alien, however brief, it is carried lightly, worn like the pattern on the skin, present in every movement, every pause, every soft and patient settling toward the seafloor. The mind is everywhere, and it is quiet, and it continues. There is something tender in the distance between what a lineage carries and what a single life is given to hold. Cephalopods have been on this planet for a very long time. The earliest of them appear in the fossil record somewhere around 500 million years ago. Soft-bodied, ancient, already experimenting with shapes and strategies that would branch and diversify into everything that followed. Nautiluses, ammonites, squid, octopuses, cuttlefish. What we call a cephalopod lineage is not a single unbroken thread, but a vast, slow flowering, a branching that happened across geological time so deep it becomes difficult to picture. The ammonites alone persisted for 330 million years. They survived extinction events that remade the world. They evolved into thousands of species, filling oceans that no longer exist, in configurations of continent and current that have long since rearranged themselves. And then they were gone, at the end of the Cretaceous, in the same event that ended the non-avian dinosaurs. But cephalopods as a group did not end. They continued. They are still here, in the water, doing the same ancient work of moving and hunting, and sensing and adapting. That is what cuttlefish are part of. Not just a species, but a lineage with that kind of depth. The cuttlefish themselves, the order Sepiida, are younger than that deep root, but still ancient in any human sense of the word. Their own cuttlebone, that elegant internal structure that gives them buoyancy and form, is a modified version of something far older. The external shell of the first cephalopods gradually internalized over the long, slow pressure of evolutionary time. The shell moved inward. It became lighter, more complex, more useful in a different way. What was once armor on the outside became architecture on the inside. That transformation took an enormous span of time. And somewhere at the end of it, there is a cuttlefish, hovering over sand, alive for perhaps 2 years. 2 years is the upper edge for many species. Some live less. Some manage a little more in the right conditions. But the general shape of a cuttlefish's life is brief by almost any measure. Brief enough that it is sometimes difficult to reconcile with the depth of the lineage that produced it. They are born knowing a great deal. Something in the structure of the egg, in the development of the embryo, in whatever passes between generations at the level of biology rather than teaching, something carries forward. Young cuttlefish emerge already capable of changing color, already equipped with the basic strategies of concealment and predation. They have not learned this. It arrived with them. That is one of the ways deep time moves through a short life, not as memory, not as anything the individual cuttlefish experienced or was told, but as capacity, as the accumulated solutions of countless generations compressed into the beginning of a single small existence. It is a strange kind of inheritance, and it is the only kind that works at this scale. What the individual cuttlefish does with that inheritance is its own. The learning it accumulates, the prey it learns to recognize, the rivals it reads and responds to, the particular texture of the seafloor it has come to know, all of that belongs to one animal in one brief window of time. And when that animal is gone, the particular version of experience it held is gone with it. What remains is the lineage. What remains is the shape of the capacity, passed forward again, arriving in the next generation as potential rather than memory. There is something worth sitting with in that. The individual life is unrepeatable. The lineage is continuous. Both things are true at once, and they do not resolve each other. They simply coexist, the way deep water coexists with the light that only reaches the surface. Cuttlefish, for much of their brief lives, seem to live with great intensity. They are attentive animals. They respond to novelty. They remember, they adjust. The studies that have been done on cuttlefish cognition suggest animals that are genuinely engaged with the particular details of their environment. Not running programs, but attending, noticing. And that attentiveness in an animal that may live only a year or two takes on a particular quality. There is not much time. Whatever learning accumulates quickly. Whatever the world offers, it must be taken in and used now. This is not urgency in the anxious sense. It is simply the shape of a life organized around presence. The cuttlefish does not know it is brief. It does not carry that awareness the way we might. It simply inhabits the time it has, fully, in the way that creatures without the concept of their own finitude tend to do. Perhaps that is its own kind of wisdom. Or perhaps wisdom is too large a word for it. Perhaps it is simply what life looks like when it is not interrupted by the knowledge of its own ending. Human beings have a complicated relationship with brevity. We tend to feel that a short life is a lesser life, that duration is a measure of significance, that more time means more meaning. But the cuttlefish asks something quiet of that assumption. It arrives carrying 500 million years of lineage in a body that will last too. It learns. It hunts. It signals. It responds to the world with what appears to be genuine interest. And then it is gone. Was that not enough? Was that not, in its own terms, complete? There are cephalopods that live longer. Nautiluses, those living relics of an ancient form, can survive for decades. They grow slowly, reproduce late, drift through deep water on a different kind of schedule. And yet, they are often considered less cognitively complex than cuttlefish, less adaptable, less curious. Longevity and richness of experience do not always travel together. The cuttlefish, with its brief and vivid life, may pack more variation, more learning, more behavioral complexity into its 2 years than some longer-lived animals experience across a much greater span of time. Duration is one dimension of a life. It is not the only one. The cuttlebone will outlast the animal that grew it. Those pale, oval structures wash up on beaches around the world, smooth and light, long after the soft body that surrounded them has gone. People find them without always knowing what they are, a remnant of something, curved and strangely beautiful, like a small vessel that carried something living and was left behind. There is a kind of fossil logic to it. The hard parts persist, the soft parts dissolve, and what remains is a record of the shape, not the whole animal but the form that held it together. The cuttlebone is not quite a fossil. It is too recent, too present. But it carries something of that quality, a durable artifact of a brief and intricate life, evidence that something was here, that it had internal structure, that it solved the problem of buoyancy in this particular way, that it was real. Ancient lineages leave these traces everywhere, not just in bones and shells, but in the shapes of living animals, in the W-shaped pupil, in the 3 hearts, in the blue blood moving through a body plan that has been refined across geological time into something that works, quietly and beautifully, in the cold, dim water of coastal seas. The cuttlefish is not trying to be ancient. It is simply what the lineage has arrived at, in this moment, in this form. It carries all that history the way a river carries the memory of every upstream bend. Not consciously, not deliberately, but completely. That is the nature of deep time. It does not announce itself. It is simply present, embedded in the structure of things that are alive right now. Somewhere in the water tonight, in shallow coastal seas, in seagrass meadows and over sandy floors, there are cuttlefish. Some of them are very young, just beginning. Some of them are near the end of their brief span, still hunting, still watching, still shifting the color of their skin in response to a world that has not stopped being interesting. They do not know they are ancient. They do not know they are brief. They are simply there, in the water, continuing, as their lineage has continued through extinctions and ice ages and the slow rearrangement of everything, with a patience so deep it no longer resembles patience. It just resembles being. The longer we stay with such a creature, the less it seems strange in the shallow sense, and the more it feels like a quiet challenge to human assumptions. There is a word people reach for when they first encounter cuttlefish in their full complexity. The word is alien, and it is understandable. The W-shaped pupil, the body that writes in light, the arms, the beak, the 3 hearts, the blue blood, the skin that seems to think. These things do not match the template most of us carry for what an animal is supposed to look like, supposed to do, supposed to be. But alien means from somewhere else, and cuttlefish are not from somewhere else. They are from here, from this ocean, this planet, this long unbroken line of life that stretches back further than we can comfortably hold in mind. They are our relatives, in the way that all living things are relatives. Distant ones, yes, with very different arrangements of tissue and nerve and experience, but not separate, never separate. What we mean when we say alien is that they do not look like us, and that is a different thing entirely. For most of human history, cephalopods lived at the edge of the imagination rather than inside it. They were sea monsters. They were the kraken, the devouring thing beneath the waves, the shape that sailors feared without ever quite seeing. The ocean was vast and dark and full of things that could not be explained, and so it was full of things that were made terrifying to account for the fear. That is not strange. That is human. When we do not understand something, we often make it dangerous in our minds. We give it teeth and intention. We make it an adversary. The science, when it came, did something gentler. It looked closely. It described. It watched the cuttlefish in shallow coastal water, in tanks, in the wild, over many patient hours. And what it found was not a monster. It found a small, soft animal with a complicated life. It found something curious and adaptable and brief. It found something that had never been threatening at all, only unfamiliar. And that is perhaps the more interesting story. Not the monster, but the process of letting the monster go. What the cuttlefish asks us to rethink, first and most obviously, is intelligence. We have spent a great deal of time building categories for minds. We have arranged them in hierarchies with human cognition at the top and everything else arranged below in descending order of complexity, of worth, of consideration. We have used brain size, and then brain-to-body ratio, and then specific structures, and then behavioral tests designed by humans to measure things humans value. The cuttlefish does not fit neatly into any of these arrangements. It learns quickly. It remembers. It adapts its behavior based on what it has observed. It solves problems that are new to it, without instinct to guide the solution. It appears to plan, in some sense of that word, to hold a future moment in something like anticipation, adjusting the present accordingly. And it does all of this with a brain that is distributed, that shares authority with the skin and the arms in ways we are still working to understand. What kind of intelligence is that? What name belongs to it? We do not have a settled answer, and the unsettled nature of that question is itself important. It means the category was always too small. It means intelligence is not a single thing with a single shape. It is a family of solutions, different answers to the same ancient pressure of staying alive in a world that is always changing, always unpredictable, always asking something new of the bodies that move through it. The cuttlefish found its answer. It looks nothing like ours. It works. There is something else the cuttlefish asks us to rethink, something quieter and harder to name. We tend to think of beauty as a kind of accident, a side effect, something that arises when function is achieved with particular elegance, but not something that is itself a strategy, a tool, a form of survival. We separate the beautiful from the useful, as though they belong to different registers of experience. The cuttlefish collapses that distinction entirely. Its beauty, the rippling bands of color, The shifting textures, the patterns that move across the skin like weather, is not decorative. It is the mechanism. The beauty is the camouflage, the communication, the warning, the courtship. There is no layer beneath the beauty that does the real work. The beauty is the real work. That is a strange thing to sit with. It suggests that in at least some places, in at least some lives, the capacity to produce something visually astonishing is not a luxury. It is a necessity. It is what keeps an animal alive, what helps it find a mate, what allows it to signal across the gap between one body and another. And if that is true for the cuttlefish, it raises a quieter question about other things, about other places where beauty and function might not be as separate as we assumed, about what we might have been calling ornamental that was, all along, essential. Then there is the question of perception, of what it means to see. The cuttlefish eye is remarkable in the ways that have already been described. The strange pupil, the sensitivity to polarized light, the ability to read the ocean in frequencies we cannot access. But the deeper wonder is not in any specific capability. It is in the reminder that perception is not a fixed thing. There is no single correct way to receive the world. There is no standard version of seeing, hearing, tasting, feeling the pressure of water against a surface. Every nervous system carves its own version of reality from the available information, selecting what matters, filtering what does not, building an inner model that is always partial, always shaped by what the body needs to survive. The cuttlefish's world is not our world, even when we are in the same water, looking at the same reef. What it receives, what it weighs, what it acts on, these are different, not worse, not better. Different in the way that two careful descriptions of the same place can be different, each true, neither complete. That is humbling in a quiet way. It means the world we experience is one version among many. It means there are ways of being present in a place that we have no access to, no vocabulary for, no way of imagining from the inside. The cuttlefish swims through a world we will never see. And it has always been there, that world, alongside ours, overlapping with ours, entirely its own. And then there is the brevity, the strange and poignant brevity of a single cuttlefish life set against all that depth of lineage, all that accumulation of evolutionary time. Something in that contrast seems to ask a question too. Not an anxious one, a patient one. What does it mean to carry so much history in such a short life? What does it mean to be the current expression of something ancient, to live fully, to hunt and hide and signal and reproduce and die without any awareness of the vast story that produced you? We do not know what a cuttlefish is aware of. We do not know what it is like to be one. We may never know in any satisfying sense. But we can notice that it lives completely within its life without apparent need of the longer view. The history is in the body. The body does not need to know it is there. There is something restful in that too. The idea that what we carry does not require our constant attention, that the deep patterns of a life can work through us without our having to hold them in mind. The cuttlefish does not ask to be understood. It does not offer itself as a lesson. It simply continues, hovering over sand, adjusting its skin to the light, extending its tentacles in the dark, completing its brief and complicated life in the shallow water of a coast somewhere, unremarked, unhurried. We are the ones who look. we are the ones who find ourselves changed by the looking. That is, perhaps, what all the rethinking amounts to. Not a new theory of mind, or a revised definition of beauty, or a corrected account of what perception is. Just the quiet experience of encountering something genuinely different from ourselves, and finding, in that difference, something that opens rather than closes. The questions it leaves behind are not the anxious kind. They are the kind that make the world feel larger, the kind that settle into the body like something welcome. That is enough. That is more than enough. And now we stop knowing and simply become. The light is pale where you rest. Not dark, not yet, but softened, the way early water softens everything before the day has decided what it is. You are tucked against something, a shelf of rock perhaps, a place where the sand meets a harder edge and the current breaks just enough to leave a pocket of stillness. You have been here through the dark hours. You know this place the way you know the difference between safe and not safe, which is not a thought, but a feeling that runs through your whole body at once. Something shifts in the light above you. You feel it before you see it. A change in brightness, the quality of it, the angle. The water is warming at its surface, and the warmth is moving down in slow degrees. Your eyes, wide, strange, reading the world in ways that have no name, open fully to what is arriving. The pupil adjusts. The world comes in not as color the way a human might name it, but as contrast, as texture, as the polarized shimmer of light bending through moving water. You read all of it at once. You always do. Your skin wakes before the rest of you. It is not something you decide. The chromatophores open like small doors, responding to the light, to the rock beneath you, to the pale sand just beyond your resting place. Your body finds the color of the stone. The texture comes next. Small raised points across your mantle, mimicking the roughness of the surface you're pressed against. You have not moved. You have simply become more accurate, more present. The rock and you are almost the same thing now. Almost. But the day is beginning, and something in you knows it. You lift from the shelf. Not with effort, with intention. The fin along your mantle begins its ripple, that continuous soft undulation, and you rise into open water with no particular urgency. You hover. This is what you are built for, among other things. This exact quality of suspension, neither rising nor sinking, the cuttlebone inside you holding your density at precisely the right point. The water holds you, and you hold the water. You are still, and you are moving at the same time. Below you, the sand is pale and ridged in shallow patterns left by last night's current. You read it, not with your eyes alone. Your arms trail slightly, and where the tips brush a drifting piece of sediment, you know it immediately. Texture, temperature, the faint chemical trace of something that passed through here not long ago. Your arms know before you have processed the knowing. The information arrives everywhere at once, and something that is not quite a decision and not quite an instinct resolves into direction. You drift toward the seagrass. The blades rise around you as you enter, long and slow swaying, dark green in the slanted morning light. Your skin shifts. The pale sand pattern gives way to something vertical, something striated. Thin dark lines running along your mantle, echoing the blades on either side of you. You are not thinking about this. It is happening the way breathing happens, the way balance happens, below the level of effort, deep in the body's own knowledge of itself. You move between the blades without touching them. The water here is quieter. Smaller creatures move in the gaps between the grass roots. You take note of them without urgency. The day is young. There is time. You pause. Something above the seagrass catches your attention. A shadow moving across the light, distant and not dangerous, but worth watching. Your W-shaped pupils take in the full arc of it. You hold still. The shadow continues on its way. You wait until it is gone, and then you wait a little longer. Patience is not something you practice. It is something you are. Then you move again, deeper into the meadow. A small fish holds near the base of a seagrass blade, almost motionless itself. You see it. You adjust. Your skin settles into the light and dark of the surrounding water, a slow dapple, nothing that announces itself. You position yourself with small movements of the fin, barely movements at all, just corrections, the kind of adjustment that takes no more energy than a thought. You are closer now, and closer. The fish has not noticed you, which is correct, which is what you intended. You wait. The moment arrives the way moments do, not with fanfare, but with readiness. Your feeding tentacles extend and return before the fish has time to understand what happened. It is over quickly. It was always going to be quick, because everything before it was slow. That is the design of it. The patience earns the precision. You hold your catch with your arms, and your beak does its quiet work. And then it is done, and the seagrass sways, and the meadow continues as though nothing occurred. Because for the meadow, nothing did. You drift back toward the open sand, carrying the warmth of the meal through your 3 hearts. They beat at their own pace, each one doing its part, the blue blood moving through you in its slow loops. You do not feel them as separate things. You feel them as a kind of continuousness, a steady, quiet persistence that underlies everything else. The light is higher now. The water is brighter. You move through a stretch of open bottom, and your skin reads the sand beneath you and becomes it. Pale, faintly rippled, almost luminous in the mid-morning light. Another cuttlefish passes at the edge of your awareness. Not close, not threatening, but there. Your skin sends a slow pulse, a broad, even wave moving from mantle to arms, a signal that is not alarm and not welcome, but simply acknowledgement. I am here. You are there. The water is wide enough. The other cuttlefish continues on. Your skin settles back to sand. The hours move the way water moves. Without announcement, without hurry. You hunt again, smaller prey this time. A shrimp tucked beneath a lip of rock. You adjust to the rock's darkness, your mantle going deep and mottled. You wait. You take it. You move on. The light begins to angle. Afternoon comes as a quality of shadow, more than a change in warmth. The water shifts slightly, a current from another direction, and you feel it along your arms, along the edges of your mantle, along the fin that has been working all day in its quiet, tireless ripple. You are not tired in the way a human grows tired, not yet. But something in you begins to orient toward the familiar, toward shelter, toward the kind of place where the current breaks and the stillness gathers. You find a patch of reef edge where coral meets rubble meets sand. You slow. Your fin's ripple softens. The jet that has been available to you all day, that quick, muscular option, the sudden propulsion, you have not needed it. Today was a patient day, a drifting day, the kind of day that does not ask for speed. You settle towards the bottom. The sand comes up to meet you. You sink the last small distance, and the cuttlebone adjusts, a tiny change in buoyancy, and you are resting without quite landing, hovering just at the boundary between water and ground. Your arms arrange themselves. Not a decision, just what they do. The light is going. Your skin, which has been working all day, reading, responding, shifting, settling, signaling, begins to quiet. The patterns slow. The small adjustments come less frequently. You are matching the rock now, the pale rubble, the deepening shadow of the late afternoon water. You are becoming still. The chromatophores close, one by one, or maybe all at once. There is no clear line between the two. You are dim now, almost dark. The texture of you matches the ground, and the ground matches the fading light, and the fading light matches the water above, which is going from blue to something deeper, something without a name in any language. A small fish passes overhead, close enough to see. You do not move. You watch it go. Your eyes are still open. They are always open. There are no lids to close. But the watching is softer now, less searching. The world is quieter, and you are part of the quiet. The seagrass at the meadow's edge sways in a current you can feel from here, a slow pulse, and the rhythm of it is like the rhythm of your fin when it is working at its gentlest, which is the same as the rhythm of water moving over sand, which is the same as the rhythm of the whole coastal world, doing what it does as the light goes and the dark comes. You breathe, not the way the word implies, but gas moves through you, the water cycles through, something in you exchanges what it needs to exchange, and you continue. Your arms are still. The water above you is dark now, a deep, soft dark, the kind that has no edges. Somewhere above the surface, the light from the day has moved to another part of the world. Down here, the dark is even and quiet and full of small things settling, the way everything settles when the day releases its hold. You are not waiting for anything. There is nothing required of you now. No adjustment to make, no approach to calibrate, no signal to send. Your skin is still, and the stillness of it is complete, the way the surface of very calm water is complete. Not empty, but finished. The rock beneath you is cool. You are here. That is all. That is everything. The dark continues around you, patient and vast, and you are part of it, small, soft, ancient, and still. Your three hearts beat their quiet, separate beats. The water moves through you. The night moves over the sea above. And somewhere in the deep, slow dark, you rest. You rest. And after all that motion, all that color, all that silent intelligence, what remains is rest. The cuttlefish is still out there, somewhere in the shallow dark, draped over a shelf of rock or hovering just above the sand, its skin making small, slow adjustments, not for any particular reason, just because that is what the skin does. It does not stop. Even in stillness, it continues. That is the thing that is hardest to forget about this animal. Stillness, for a cuttlefish, is not absence. It is another kind of presence. We spent a long time with it tonight. We watched the skin read the seafloor and paint itself back into the world. We followed the eyes as they gathered polarized light into something we cannot fully imagine. We felt the slow undulation of the fin, the patient drift, the sudden and precise extension of tentacles towards something unsuspecting. We sat with the strangeness of a mind distributed through arms, through skin, through the quiet hum of a nervous system that does not concentrate itself in one place, but spreads out, attending to everything at once. What a way to be alive, and what a brief way to be alive. A year, sometimes two, long enough to learn, to hunt, to find another cuttlefish in the dim water and speak to them in light. Long enough to leave eggs tucked in darkness, each one a small dark comma waiting to become something astonishing. Then the body is done. The skin goes still. The color fades for the last time. And yet the lineage continues. It has continued for a very long time. There is something in that worth resting with. Not sadness, exactly. Something quieter. The sense that brevity and depth are not opposites. That a life can be short and still be full of perception, of problem solving, of the strange inner weather of a cephalopod mind moving through a world it reads differently than we do. The cuttlefish does not need a long life to be remarkable. It needs only the life it has. Let your jaw be soft now. Let it go slack, easy, unclenched. Let your hands lie open wherever they are, palms loose, fingers still. There is nothing to hold. Your body is heavy in the way it only becomes when the day has finally finished asking things of you. You are not needed anywhere. You are exactly where you should be. Somewhere far from here, in shallow coastal water, a cuttlefish is doing what cuttlefish do in the dark hours. Hovering, watching, adjusting. Its skin moving through patterns no one is there to see. Or perhaps patterns that are not for anyone. Not signals, but simply the body continuing to be itself. The way a sleeping person's breath continues without intention, without effort, without asking. That is what this creature offers in the end. Not a lesson, not a mirror, just the quiet fact of its existence. Soft-bodied, ancient, improbable, and still here in the cold, and the dark, and the salt, and the pressure, finding ways to vanish, and ways to appear, spending its brief time being something the sea has never quite managed to repeat. You have spent time with it tonight. That is enough. That is more than enough. Your eyes are heavy. Let them be heavy. Let the weight of them settle. Let the weight of everything settle. You are held, the way water holds whatever drifts through it, without asking, without condition, without effort on your part. The cuttlefish continues in the dark. You are still. Sleep well and good night.